Welcome to our maths. Today we're doing projectiles. Stunt person aims to perform a motorcycle jump over road buses. The road bus has a total length of 50 meters. And the ramp leading to the first bus has a height of 4.5 meters. The landing ramp at the far side has buses has also a height of 4.5 meters. And for safety reasons, the maximum height the motorcycle reaches above the ground during the jump should be 77 meters. So modelling the stunt person and the motorcycle as a single projectile, find the speed at which the motorcycle should leave the ramp and the angle at which the ramp should be inclined to the horizontal. Those are all our key information. So this has to be 50 meters. And maximum height 7 meters. If you want, so this total displacement would be 7 meters minus 4.5, so it's 2.5 meters. Now that is the case because if you have a ramp and you want to reach 7 meters, and this is already 4.5 meters above the ground. This is the total distance that you need to cover to get to that 7 meters, which would be 2.5 meters. Now, let's use this equation, v squared equals u squared plus 2as. And this equation will give us value of u. And since we're doing vertical, and this a motorcycle is going to reach ground, can assume that the velocity is going to be 0 as when it stops acting under gravity. That's when the final velocity stops acting under gravity. Is 0 since touches so 0 equal to u squared plus 2 minus g times 2.5. Now, if we want to find initial velocity, we can simplify this now. This would equal to minus 5g. Since we times it by 2.5. And now move it over to the other side to get the value of u squared. 5g equals u squared. Then we square root both sides to get u on its own. And u equals 7 meters second. Now this is important, so to keep this value noted, because this will help us find the speed. Now let's find out the time from this. V equals u plus at. This equation will help us work out the time, so since we already got the variables u, a, and t, and v. So v is 0, as we stated before. And u is 7. And a is minus 9.8. Bring the minus 9.8 over to the other side. 9.8 t equals 7. 7 divided by 9.8 equals t. T equals 507. Now we can work out. We can assume that since it's symmetrical in this equation, and it must be land perfectly onto the ramp here, we can assume that the maximum horizontal distance is reached should be 25 meters before it falls. So since the landing ramp has 4.5 meters and the starting ramp has 4.5 meters, we can also assume that Q will give us the maximum due to symmetry of both land ramps being the equal length. Now, all we need to do is use the horizontal. 0, and this is because acting on a horizontal plane, we assume that gravity doesn't act upon it, since gravity is a vertical vector and we're dealing with horizontal. T would be 507. Now, since A is 0, we can use the formula 20 S equals UT. Since it would originally be S equals UT plus half AT squared, but S equals UT plus half 0T squared makes S equals UT plus 0, so resulting is S equals UT. And then 25 equals 507T. 25 divided by 507 equals T. T equals 35. And we can work out the speed. Now that we have U vertical and U horizontal as 7 and 35 respectively. Since we worked out U as 7 here. Now, let's imagine this is like a sort of graph. 7's here and 35's here. And we want to work out what's the value of this line. And imagine this is like a velocity. Speed time. Speed time or slash velocity time graph. And this is also a triangle. Now we put these values here since we also want to find the angle of which it's projected from. But we know it's projected from 35 meters per second and projected with 7 meters per second. So 30 square root 35 squared plus 7 squared equals speed squared. So square root of 35 plus 7 equals squared plus 7 squared. Speed equals 2. And use the same logic to work out tan minus 1. This is adjacent opposite, so we can do tan minus 1 7 over 35. Give us